Hello and welcome to the PTV Vissim Viswalk webinar, Manage Vehicular and Pedestrian Flows during COVID-19. With the current COVID-19 pandemic, there are many screenings carried out. Today, we will look into a case study in Shanghai, China, where we will utilize our traffic simulation software, PTV Vissim, to realistically simulate the scenario. I am Hao Min Tan, Solution Specialist at PTV Asia Pacific in Singapore. Today, I will be utilizing materials from our headquarters in Germany, as well as from our colleagues in China. Before we start, let me give you some technical information about the webinar. While the microphones of the attendees are muted, you can contribute by posting comments and questions via the questions window. These are only visible for us here at PTV. After the webinar, we will be around for some time to answer your questions. There will also be a recording of the webinar that will be distributed by our colleague. Our case study today will focus on PTV Vissim, but features that will be highlighted in the webinar, namely user-defined attributes, attribute decisions, and formula-based routing, are also available in PTV Viswalk. Also, for your information, these features do not require additional modules in Vissim or Viswalk. But for attribute decision and formula-based routing, they are relatively new and available since Vissim 11. For those of you that are not familiar with the difference between PTV Vissim and Viswalk, here is a short summary. Both Vissim and Viswalk share the same software base. Viswalk is dedicated to applications which focus on pedestrians only, without any vehicle movements, and uses an area-based movement model, the so-called social force model. On the other hand, Vissim originates from micro-simulating road and light rail traffic, both in urban and interurban contexts. Most times, it's not just one or the other, but a combination of both, like at intersections or with public transport. Therefore, as soon as combinations of both worlds are to be examined, PTV Vissim and Viswalk together provides a single seamless application to simulate almost all kinds of human and autonomous mobility. Let us now dive into the case study today. From January 23rd, Shanghai extended its inspection of vehicle license plates from Hubei entering Shanghai territory along highways, as well as other measures including body temperature checks, identifying people with respiratory symptoms such as cough. In our scenario testing, we have selected only license plates and body temperature screening for simplification. In this webinar, I will show you how this scenario is carried out by utilizing PTV Vissim. The features highlighted could also be extended for other scenario testing, even for pedestrians in PTV Viswalk. This rather simple Vissim network shows the scenario we will test today. Here, I would like to show you various components in the model. First is the road network, which is the base of all vehicular movements. Then, it is the vehicle demand, which is used to populate the model with different vehicle types. The stop sign ensures vehicles stop for a duration based on the time distribution set by the modeler. These components will be our start point to build up the model to incorporate the next components, which are the attribute decisions to assign license number and maximum temperature to each vehicle, the routing assigned to each vehicle based on conditions stated in formulas. This then ensures vehicles either pass through or make a detour to the checkpoint. Typical vehicle screening properties include license plate to identify the origin of the vehicle and therefore its passengers, temperature of passengers in the vehicle. Other screening measures could include identifying people with respiratory symptoms, such as cough and flu, exposure to wild animals, travel history, and many more. To accommodate this, you can define an unlimited number of attributes that are customized according to your requirements. These are the user-defined attributes. User-defined attributes, what we call the UDAs, can be defined for all static network objects, also individual vehicles and pedestrians. UDAs are similar to other attributes predefined in Vissim or Viswalk, where they are accessible through lists and quick view window. Attribute decisions comfortably allow for setting values for attributes, like for example, the personal properties mentioned before, anywhere in your network. This can either be a fixed or a random value taken from a distribution. To assign random value, there is a type of distribution known as free distribution, which is used to define any possible value between the minimum and maximum values. This is based on an example since Vissim 11. In this example, we can see that there are pedestrians in the network. When a pedestrian passes a certain area, they are assigned an attribute. For example, there are people who want to purchase magazines, others would like to get food, and some others would like to purchase train tickets. Other attributes are also defined. Example, those in white denotes calmness. They are not in a hurry and all wishes are satisfied. And those in red are in a hurry to catch the train. Those who have missed the train are in black. And for those in pink, they are the worst off because on top of missing their transport, their wishes are also not satisfied. Let us now go straight into the Vissim model. And here I will open up the model for you in Vissim. Here in our network, already set up in the model are the links and connectors, and also the vehicle input, which assigns 1,000 vehicles per hour. And another network object as already defined is the stop sign to ensure all vehicle classes dwell for about 20 seconds at this point. So right now we want to create and define the free distribution. To do that, let's go under base data, and under distribution, we select free. And similar to other distributions in Vissim and Viswalk, you can again define the minimum and maximum threshold. To do this, I first create the empirical distribution, and this one I will name it as to assign the license number. And because I want to assign license number of 5-digit, therefore here in the maximum threshold, I will assign a 5-digit number. You can also, based on your local country, your local county, your local areas, have 4-digit, 3-digit license number based on what is the local use case. For here, we will put the upper threshold as 30,000. And then the lower threshold as 10,000. And then again, I can define here straight away in this graph, the median and the other medians as well. But for me, I prefer to go straight into the list here. And what I would do here now is assign that 90% will be just shy of 20,000. So therefore 19,999.999. So what happens here is that 90% will be assigned 10,000 to just shy of 20,000, and another 10% will be assigned 20,000 to 30,000. So this will then have the free distribution for the license number. To create another free distribution for maximum temperature, similar steps as well, I add an empirical distribution and straight away go into the graph here and call it as maximum temperature. Maximum temperature of per vehicle. And my maximum threshold, I will put it as 39 degrees Celsius. My minimum threshold as 36 degrees Celsius. And again, the median, I will just add in the list here and then define it as 90% to be between 36 degrees Celsius to 37.1 degrees Celsius. Once free distribution is defined, we can now allocate the vehicle attribute decisions. To allocate attribute decision, I then click on the network object, and I will say that at this point, they will be allocated the attributes. And from here, I again name it as license number. And then the distribution were based on the license number free distribution we created earlier. And here, again, I create another one on top of it, which is for the maximum temperature. So I can simply duplicate it and name it as maximum temperature. And then on the distribution, allocate maximum temperature distribution. And what you note here is that which attribute do I want to allocate this number to? And if I click here, there is a lack of selection based on the predefined one. If, let's say, when it comes to this exact license number and maximum temperature I want to define, which is not in the list. So right now, what I can do here is then I can create a user-defined attributes. So I can go straight into base data and then user-defined attributes. And because I know I want to allocate for each vehicle, so under network object, vehicles in network, I can right click here. Straight away, I say create UDA. And you can see here, object type vehicles in network for the short name license number. And here for short names, typically you should not put any space in between. So there is no space in my short name. But in my long name as well, I do not create a space. And you can, again, have a longer name and then add some comments to it. But right now, I will leave it as it is. And for the data type, I put it as floating point number. And then the data source will be data, which will be allocated based on the free distribution. Thereafter, I can click OK again. So now we have license number for the UDA. Again, I will create another one, which is the maximum temperature. And again, the data type and the data source type is the same. The rest remains the same as well. Then click OK. So once that is done, I can now go back to my my attribute decision, which I can show here. And under attribute now, I can select the UDAs that I just created. And as you see here, the UDAs will quite obviously be under this black mark here, this signage, and then you can click on it, or you can just search directly from the list here, and then I just double click on it. And for license number, I select attribute license number. For maximum temperature, I select attribute maximum temperature. So once that is done, I save my network and I play simulation to see how it goes. So right now, each vehicle comes in, and once they pass the vehicle attribute decision, I just pull out the list here. They are allocated the license number and maximum temperature. But I want to refine my UDA. How do I do that? Is if I go back to the UDA list, and again, I click here. And for now, I want to, again, either select from here or you can select from the network object list, vehicles in network. And for the short name, I want to refine my license plate because usually for license plates, it incorporates the license number on top of that. Also some sort of letter that signifies where the vehicles is from, where the vehicles are from, and therefore where the passengers are from. So under my short name, I create one that's called license plate. And under data type, instead of number, it is now text. And data source type, instead of just data, I put it as formula. So I want to say that if my license number is less than 20,000, it is A. If not, it is B. And therefore, this will provide a letter for the license plate. And of course, I want to add the 5-digit license number. To do that, I can just simply click plus here. And then from the drop-down list, again, select license number. But if you see here, because the data type is text, that's why license number as a number, you have to add another function called number to text. And again, select license number. Once that is done, then I click OK. So this incorporates my license plate formula. After having the license plate formula, I also want to have a label for each vehicle during the simulation that shows the license plate plus the maximum temperature. Then this I can easily identify during my simulation which route they should be taking. To do that, again, I create another UDA. So under Vehicles in Network, create UDA. And here again, I name it as my label. And data source type as text again, and formula. And again, I want to put in license plate and the maximum temperature. To do that, I just simply select this license plate plus, again, you need to add the function of number to text for the temperature. Then I click OK. So when I want to show my label for each vehicle, I need to go into Edit Graphic Parameters for my Vehicles in Network, and then tick on Label Visibility. Instead of showing the number of each vehicle, I select to show my label, which I define as license plate plus maximum temperature. Once that is done, again, I save my model and I play the simulation. So what happens here now is that you have the license plate plus the temperature. But since there is no space in between, it's very hard to see. So how do I refine further my label? Is I can go again to it, and then in between, if I want to create a space, I just add this in and then click OK. Again, play the simulation. Now it is much better where you can identify between the license plate and also the temperature. But for license plate, there should not be any decimal points, and for temperature, it should maybe be maximum 1 decimal point. To do that, I can just stop the simulation, again, go into my license plate, and then say that if I do not want any decimal point, I just state 0. And then for my maximum temperature, depending how many decimal points you want, for here, I just want 1 decimal point. So I just click on type in 1 and then click OK. If let's say I want to refine it further, saying that, okay, I want to differentiate between the units of degree Celsius and degree Fahrenheit, what I can do again here is that I can plus and then let's say put in C and then click OK. Play the simulation again. And here you see that it is much enhanced, the labeling, where you have license plate identifying where the vehicle is from, plus the 5-digit license number, and then plus the maximum temperature of each vehicle. So once that is done, I want to, based on this attribute, allow the vehicles to either go through or go towards the detour. So what I have to do now is then create formula-based routing. But before I go into that, let me go back to the slides and share with you more about formula-based routing. Routing through the network can be based on any combination of attribute values by means of formula-based routing. This results in individual and tailored paths for pedestrian and vehicular movements. Formula-based routing is available both for static and partial routes. Routes can also be nested as well as combined with fixed route proportions. Another example here, since Vissim 11 as well, based on the height attribute of individual pedestrians, they are routed through the door or to the side. In the case where pedestrian is lower than the height of the door, the pedestrian will utilize shortest route through the door. Otherwise, pedestrians will utilize the detour around. So this is just what I wanted to talk about formula-based routing. And once that is done, let us go back to the model and define it in our model earlier. So to define this formula based on the logic we want and the attributes that we created, what I can do straight away is under route static. Here, after the stop point, I create one that either goes through or goes to the detour. And under route choice method, instead of static, I select formula. And for the through movement, the formula logic, what I want it to be based on will be that the license number should be below 20,000 plus the condition of N, maximum temperature should be below or equal to 37.1 degrees. So once this formula is done, basically it says that for the through movement, the license number must be less than 20,000 and the maximum temperature must be less than or equal to 37.1 degrees. So once that is done, I click OK. And for the detour to the checkpoint, if I just copy and paste the formula here and then refine from here, I can, instead of being less than 20,000, it will be more than or equals to 20,000. And instead of the condition N, it will be the condition OR. And instead of less than 37.1 degrees, we make it as more than 37.1 degrees. So once that is done, I click OK again and save my network and play simulation. So this first vehicle meets the condition of through, both condition where it is less than 20,000, the license number, and the temperature less than 37.1, so it goes through. Second vehicle as well will be going through. For the third vehicle, because it falls under one of the condition that it is more than 20,000, the license plate, so it will go to this detour around. And maybe let me just quicken the simulation here. So the next two again will be going to the through movement. And for this vehicle, because the temperature exceeds 37.1 degrees, it should be routed to the detour. So this simple model just shows a bit about this attribute decision, the formula-based routing, the UDAs that we created, and then based on that, how they are routed. So let us go back to our presentation. Let me wrap up quickly what you've seen today. For the case study highlighted today, two attribute decisions were modeled to assign individual vehicle and with license number and maximum temperature based on the free distribution defined. This distribution can also be further enhanced, of course, based on data collected in field. Also, 4 UDAs were created, license number to assign the 5-digit distribution, maximum temperature to assign highest body temperature among all passengers in the vehicle, license plate incorporating the text and numbers typically seen on number plates, my label to showcase individual vehicle license plate and maximum temperature during simulation. Formula-based routing was assigned where the logic is based on attribute condition, vehicle origin, and temperature. Based on this logic, vehicles either pass through or detour to the checkpoint. With individual tailored paths based on attributes defined, it can be applied to vehicle passenger screening for COVID-19 compliance, which you saw today, airport immigration clearance, public stations, hallways, security check, evacuation during fire events, and many more. Before ending the webinar, I would like to show you a video of how, with features highlighted today, coupled with more advanced modeling skills, screening scenario at supermarkets can be modeled in PTV Viswalk. We are now at the end of this webinar. Should you have any more questions, you can still ask using the questions window. We will stay online for a few more minutes and reply to you. Okay, so I have a question here. It says that, may I know Vissim can model vehicles and pedestrian interaction at non-signalized junction? Yes, that is possible. What happens is you create a link and then you can activate that it is a pedestrian link. So from there, you can then define the conflict area where you can say that either vehicles or pedestrians have the priority. For me, I do not see any other questions. Of course, if there are further questions after this, feel free to email to us and then we will reply to you. And other than, sorry, hold on. Let me check again. Is this webinar going to be uploaded to YouTube? I'm not sure YouTube, but it will be distributed. Yeah, it will definitely be distributed to the attendees. So, are there any social force parameter developed or calibrated to put in use for social distancing? So right now, of course, PTV Viswalk was not developed for this phenomenon, but we can share certain models that was done by our by our developers that incorporate maybe same speed that vehicles can traverse on, or certain calibration effect to cause pedestrians to maintain a distance in between them. I noticed that PTV Vissim also have the option to model pedestrian movement. So what is the difference between it and Viswalk? Okay, so in PTV Vissim, yes, you can model pedestrians, but the pedestrians will be modeled based on this vehicle input, and their behavior will be based on more the car following model instead of the Viswalk model, which is the social force model. So these different behaviors then signifies, especially if you want to evaluate pedestrian outputs, it should be based on more realistic pedestrian movements. So then the social force model will be better than utilizing the car following model for pedestrians. Where can we watch the other recorded webinars? This one, there is the website in PTV, there is the webinar archive. And also if you go on YouTube, there are many webinars also under PTV. And also there is a website showing upcoming webinars that you can register for, like this one. Is it possible to show physical distance between agents in Vissim to adhere with, say, minimum of 2 meters? So right now under evaluation output, direct output, what you can do is you can, for each time step even 0.1 second, let's say, you can show basically the coordinates of all pedestrians. And then based on these coordinates, maybe you can create a UDA that say that, okay, what is the distance between them? So you can do a bit of post-processing after, or if you want to see directly in the simulation, you can create some UDAs to assign these values. Can these formulas be applied via COM? Yes. If you mean the formula-based routing or the UDAs, yes, it can be incorporated via COM. This one then easily in the script, you can easily create it as well. All right, so there are a lot of model social distancing between agents. As mentioned, we are able to share some models developed by the developers to show how this is adhered to, maybe by allocating more constant speed between pedestrians. Looking forward to see the models developed by PTV to understand the pedestrian flows. Can you please provide email ID for further communication? Right. So for this one, maybe I just put in I will send to all my email address so you can reach out to me easily. Okay, I think other than that, I don't see any other questions. So thank you for your interest in microsimulation and for watching our webinar. Have fun modeling with PTV Vissim and Viswalk. All the best and take care.